All right, welcome to the exciting formative assessment, 3.3, I guess. Yes, arc problems. Okay, so this thing is being launched, and it's on a level field, at least for now, right? Okay, and it's being launched at 75 degrees. So that's like, psh, like that, and it's 27.2 meters per second. That's a decimal point there, and that's 75 degrees. Right, and the first thing we're going to do is we're going to figure out the x and y components of this thing. Right, so there's the x, there's our y component like that. And of course, these are always trig angles, so it's easy, right? Our x component, our vx, right, is just, what is it? It's 27.2 cos of 75, right? And the velocity in the y direction is, what is that? It's 27.2 sine of 75. Uh-oh, now I've put parentheses around one of these. I got to put parentheses around both. That's what kind of person I am. Okay, so here we go. So 27.2 cos 75, and I'm going to store that in A just for kicks. And 27.2 sine 75. Oh, let's store that in B just for kicks. Okay, so let's see. I'm getting that my initial velocity horizontally is 7.039870399 7.03999. Is that 5 sig figs? Yeah, it is. You're probably okay with 4, but I'm going to carry 5 because, I've got a bachelor's degree in physics. 1, 2, 3. Yeah, that's what it is, right? Now, of course, the initial velocity vertically is different, so it's, what is it? It's 26.273 meters per second, right? Okay. Now, the things that are always true are always true. So this is, there's no acceleration there. This is negative 9.81, right? And then, we need something else. Ultimately, what we really know for this thing, because it's going to, its trajectory is going to, it's going to do that, right? We actually know that its displacement here is 0. I don't use that. I use this trick. It's a little bit easier mathematically. And that is that if it lands on the level ground, right, it's on a level field, right, okay, that this final vertical velocity is negative 26.273. Okay, did I get that right? I did. Okay, now we're all set. We actually have 3 things here, right? And and the reason that that's negative, I guess that's the, you throw something up in the air, it comes back down with the same velocity if it's the same elevation. Neglecting air friction, right? Okay. And I think the way this will play out is we'll find time will go across, and then, we also know this, 7.0399, and we can also now find S. Okay, so let's do this. Let's find the time here. Let's see. I think I'm going to use this. I'm going to use V equals U plus AT. I'm doing this in the vertical direction, right? So minus 26.273 equals 26.273 plus negative 9.81 times t, right? And, don't be a nilly and say, well, this adds to that and makes 0. No, no, no. You subtract it from both sides. So that thing times 2 divided by 9.81. I'm getting that the time is 5.3564, I'll just say, seconds. 5.3564, right? And of course that can just go right across here. Crosses the blood-brain barrier there. 5.3564. And it's the only thing that we can just bring across. It's the only thing that's the same, right? And then we want to find the horizontal distance that it goes. Oh, hey, we got that right. Look, there's the time in the air. And then to figure out the horizontal distance it travels, I'm going to use, and this is so this was a vertical thing, right? This is a horizontal calculation, right? And then all we ever do is we use S equals UT on this side, right? And since we have U and we have T, we're going to use that, right? It really is a plus 1/2 AT squared, but it went away when the acceleration is 0, right? Okay, so let's see. S is equal to 7.0399 times 5.3564. Okay, so that guy times 7.0399. And I get 37.70 something. 709 roughly, right? Okay, so let's see. Do we have the right answer? We do. Look at that. That's exciting. Okay, so basically just the time you're in the air, you multiply that by the horizontal velocity. That gives you this guy, 37.7 meters. Does that give you a happy feeling? That's kind of cool to be able to do that. You can, of course, double check that distance with the range equation. Okay, but you got to learn how to do that, don't you?